This is AP Calculus, Lesson 4-4. I'm currently bouncing Riley, which means that my pen is going to be bouncing, as you can clearly see. No crazy intro because he's trying to sleep and I'm trying to record. So, mean value theorem. What the heck is that thing? You remember this all the way back from, was it Unit 1? I think it was Unit 1. Wow, yeah, a long time ago. Do you remember what mean value theorem said? If so, then you have a good memory. This is what you need to write for mean value theorem. This is the definition of mean value theorem. It's f prime of some point, so some point c, f prime of c is equal to the average rate of change, the secant line. So f of b minus f of a all over b minus a. Again, I have a writing tablet, but me bouncing up and down is not helping my handwriting. Alright, what does this thing mean? This means, what does it interpret as? It means that the slope, the tangent slope, is equal to the average rate of change slope. This is the slope of the secant, this is the slope of the tangent. So if you're just talking about slopes, this translates as the tangent slope is equal to the secant slope. And I want to show you what that means graphically too. And I really apologize for that bad handwriting, but again, gotta get this guy to go to sleep. So if I have some curve, let's go ahead and just draw some random curve. Let's go ahead and draw something that looks like this. There's my curve. Maybe I want to make it slightly more curve-y like that. If I take 2 points, I'm going to take my points, and the points A and B always matter. You have to figure out where your start and end is. I'm going to say my A, my x value of A is there, my x value of B is right here, so there's my point B comma f of B. If I look at the secant line, I'm going to do the secant line just in blue. If I do the secant line between those 2 points, there's a slope. You can see that the slope looks like maybe about a positive 1/2. All I'm saying, all this mean value theorem is saying, is that this slope of the secant line has to be, that slope has to exist as a slope of the tangent somewhere in here. And here's what it also means graphically too with technology, is I can copy and paste that line, I can change it to red, and I can move that point around. Where do I move? Come on now. Okay, it's going to be hard to grab this thing while bouncing up and down. Give me a sec. Okay, I can, no. You guys have no idea how hard this is to, okay, I got it. Don't let go. I can move this point around until it touches the curve once, and there it is. The point of tangency, that x value that I was looking for, which was actually c in this case, where was that point? Sorry, Riley, you're okay, you're okay. That point was right here. That c value that I was trying to find happened to be right here. We can find that value of c. That's what we're doing today. So that slope of that secant line exists somewhere, and the x value that it exists for that point of tangency is right there. That's what mean value theorem is trying to say. That's what we're going to be doing today. So I have one example, and then we're done. I don't think there's a backside to this. Nope. One example. So this is a very AP type question that they'll ask. So C is a number that satisfies the conditions of the mean value theorem. The mean value theorem is always defined with this C in there. It has to be C. And here's the function that's defined. We don't know exactly what that looks like, but we know it's defined on that interval. There's our A, there's our B. It tells us right there. A is 0. Let's go ahead and write that underneath this. A is 0, B is 1. And it's asking us, what is the value of C? Where is this x-coordinate where the point of tangency exists? Okay, so how do we do this? We use the definition of the mean value theorem. We have to find the derivative of our function, replace everything, all the x's with c's, take the derivative, replace the x's with c's on the left, and on the right, we plug in a and b into our function and divide it all by b minus a. So let's go ahead and do that. I'm going to start by rewriting the mean value theorem. This is something that you should always be doing when you're doing example problems on the homework. F prime of c is equal to f of b minus f of a all over b minus a. Okay, well now I need to take the derivative and replace everything with c's. If I take the derivative, this is going to be 3, it's not x squared, it's c squared, minus 2c. That's the left-hand side. The right-hand side, I'm plugging in b, I'm plugging in this 1 into this function. So f of b, 1 cubed is 1, minus 1 squared is 1. So 1 minus 1 is just 0. Here's f of b, that's 0, minus f of a, that also is 0. Because plugging in 0, 0 minus 0, 0. All this is going to be divided by 1 minus 0, which is just, we'll just write here 1 minus 0. This is 0 divided by 1 on the right hand side, which means it's just 0 on the right hand side. So if I come down here to my new line, this is going to say 3c squared minus 2c is equal to 0. Now I need to solve. This is just a simple quadratic. Factor out a c. C is factored out of 3, got some lag, 3c minus 2. And then that's still set equal to 0. Alright, there are two answers that you're going to get. C is equal to 0, because this c is set equal to 0, and the zero product property says this 3c minus 2 is equal to 0. 3c minus 2 is equal to 0. When I solve for this, I get c is equal to positive 2/3. Alright, so we need to say if the c satisfies the conditions of the mean value theorem between 0 and 1, what is the value of c? Technically, that is an endpoint, and I don't know if we can take the derivative at an endpoint, so let's go ahead and exclude that answer. That is an endpoint. We need somewhere in that interval. Even though it has an equal to here, less than or equal to, this is still the derivative at 0, and the derivative doesn't exist at endpoints. So our correct answer is c is equal to 2/3. That concludes the notes. Help the substitute out. I don't know who the substitute is. After you finish your summary, grab your homework, worksheet 4-4. I forgot to include it in the lesson plan for the substitute, but you guys know where it is. You look at that black filing thing, and then if the slot closest to you is period 1, the next slot is period 2, you're period 3, so go to that third slot from the bottom, and there should be 3 worksheets 4-4 for the homework. All right, thanks.